Okay, first let's take a look at example number 8, which we were just about to begin in class. So it's a 40-kilogram cart that's being pushed across a level sidewalk with a force of 300 newtons acting downward at an angle of 30 degrees. So the force this time is going this way. And the angle is always with the parallel to the surface, so right in here is 30 degrees. So this is 300 newtons. And so this is the Fx component, and this is the Fy component. Of course, there's an Fg still acting, an Fn, and acting backward opposing the motion will be friction. If the cart is accelerating at a rate of 1.8 meters per second squared, so that's my Ax, what is the coefficient of friction? So we're looking for mu. So again, you might want to start by finding the components. The x component is the adjacent side, so it would be cosine. So cos theta is equal to fx over f. So fx is equal to f cos theta. And if you find this value, it's 300 newtons. Cos of 30. Cos of 30 is 0.866, etc. times 300 newtons, 259.81. The x was the adjacent, the y is the opposite, so it must be sine. So sine theta equals Fy over F. So Fy is equal to F sine theta. So Fy is equal to 300 newtons sine of 30. Sine of 30 is 0.5, a half. So this should be 150 newtons. Okay, so now we have our two components. Remember, once you have your two components, the full force, the 300 newtons, doesn't enter into the sum of the forces in the x or the y, because it's not going in the x or the y, it's going at an angle. So that's why we find the components. So then we start where we always start, sum of the forces in the y. And this cart is still not moving in the y direction, so MAy is 0. When we do the forces in the y, there's an Fn, an Fy, and an Fg. Assuming that we call up positive, then Fn will be positive, Fy will be negative, and Fg will be negative. You're always trying to solve for Fn when you do this, so you take the other two terms over and they become positive. So Fg plus Fy. Fg, we know, is just mg. So it's 40 kilograms times 9.81 meters per second squared. And our Fy we found over here, it was 150 newtons. Okay, so 40 times 9.81, 300, 150, 542.4 newtons is my normal force. Okay, so where do I go next? Well, if I go to friction, I can't find it because I don't know my mu. So let's go to sum of the forces in the x direction. And in the x direction, there are two forces, Fx and friction. Assuming direction of motion positive, it'll be Fx minus friction is equal to Max. Okay, we're looking for mu, which is inside the friction. So you might want to, because you know friction is equal to mu Fn. So you might want to sub mu Fn in here. So Fx minus mu Fn is equal to Max. Just to make your life easier, you could solve for friction here and then plug it in to the fun equation, but you could do it all in one step. So if you sub this for mu Fn and now rearrange for mu. So take your mu Fn over to this side, your Max over here, so it'll be Fx minus Max will equal mu Fn, and then to get the mu alone, divide by Fn. Now, if you did it the other way, this would just be friction here, and then you would go down here, and to get mu, you divide by Fn. So we're just doing this step all at once instead of in two separate ones. Okay, so you divide both sides by Fn, this goes. So mu is equal to our Fx, which was 259.81 newtons, minus our m, which is 40 kilograms, our a, which was 1.8 meters per second squared, divided by our Fn that we found there a minute ago, 542.4 newtons. Okay, and when you do this, you should get a mu of 0.34625. All right, so that's an example of the force going down at an angle. Earlier in class, we did an example of force being pulled up. So pulled at an angle means upward, pushed at an angle will be downward. Okay, so now that we've done that, we're going to go and look at the homework questions.